So that's the end of that example. And I do want to make one more comment because a lot of people find this idea tricky when they first see it. The idea of using parameters to describe the general solution to a linear system. So I want to actually add a couple more thoughts to this. Now I want to make it absolutely clear though, this example is finished. Anything I write from now on would not normally be added on to the end of this. This is the end of the solution to this example. You wouldn't now keep on going to write what I'm about to write. But I just want to write down a couple more comments about this. So here's the idea behind parameterizing a system like this. What if I decided to pick values for my parameters s and t? Because that's how you should think of parameters. They're little placeholders that can accept any value to plug into these formulas here. So it can be any real numbers at all. So let's try a simple case. Let's take s equal to 0 and t equal to 0. If that were the case, then what would this solution look like? Well, then you'd have x would be equal to, well, s minus 2t plus 5. That's what x is, right? At s minus 2t plus 5. Well, plug in s equals 0 and t equals 0, and you're going to get 0 minus 2 times 0 plus 5, right? So that just ends up being 5. What would you get for y and z? Well, y would be, well, what was y? Y was the second coordinate, it's just s. So you would just plug in s equals 0, y is equal to s, which is equal to 0. And then what about z? Z was equal to t, right? That was what we had for t. In fact, t was the parameter we assigned for z. It came from up here. If t is also equal to 0, well then we'll plug in 0 for t and get 0 as well. Oh, I just caught this error. X was not equal to 0. This is equal to 0 minus 0 plus 5. This actually should be a 5. So that's an error. So we got x equals 5, y equals 0, and z equals 0. So this choice of parameters corresponds to the solution. Let me add this in blue. So this yields the particular solution, x, y, z equals 5, 0, 0. Right, so that's one particular solution to the linear system. So what's the significance of that? Well, that means if I took x equals 5, y equals 0, z equals 0, and I went back up to my original linear system and I plugged those values in for each of the variables x, y, and z here, I would end up with the equations all being satisfied, because that's what it means for an assignment of values to be a solution to a linear system. So this choice of parameters, s equals 0 and t equals 0, that gives this solution to the linear system. But there's other solutions, right? What if I took a different choice of values? So how about we try s equal to 1, t equal to -1. That's another choice for parameters. There's endless choices for our parameters, but that's another relatively straightforward, simple choice. What would that give you? Remember that x was given by the formula s minus 2t plus 5. And if you plug those values in, you'd have 1 minus 2 times -1 plus 5. And what does that give you? This is really just 1 minus -3. So that'd be like 1 plus, or sorry, this would be 1 plus 2 plus 5, so that would give you 8. And then y, well, y was equal to s, right? So y is actually going to be equal to +1. And z was equal to t, and our choice of t here was -1. So that gives you your values. So then now this choice of parameters, s equals 1 and t equals -1, this yields a different solution. This yields the solution given point form by x, y, z is equal to 8, 1, and -1. So that's a different solution. And the point, just to hit this home, what does it mean to have a particular solution of this form? That means if I took x equal to 8, y equal to 1, and z equal to -1, those three assignments would satisfy all three of these equations as well. But that's a completely different solution, right? And that's what you're trying to describe. When you write down the general solution, and I say the general solution is given by x, y, z, each one of those three variables given by their respective formulas over here, where s and t are arbitrary parameters, you're really describing all the possible solutions you could ever have. You're describing it all in one line. That's why these parameters are powerful, and that's why it's useful to express the answer in that form. So this particular solution and this particular solution here, those are just examples, but you could keep on going and generate as many solutions as you like.